Looking good. Do you want to remove those coasters there?
Okay, so just allowing people to trickle in. I think what I'm looking for is my other phone so that I'm able to read comments. Right. I see people are trickling in. We are almost ready to go live. I hope that you guys are ready with your questions. But I actually had been requested to look at one of the exam papers. All right, so I chose the 2023 exam. All right, so I just want to just start connecting so that we can be able to start in just a few. Right, otherwise, okay. I've got my technical team here that's kind of directing me. All right, are we live? We're good? Okay, let me just get properly seated. Hi guys, I hope that yesterday, for those of you that wrote the May-June exam, I hope that you really wrote well. And really guys, I do know that May-June exams can sometimes be frustrating, you know, because of the time that you've had to prepare for them, depending on your circumstances, you know, depending on where you are. So today, I don't want you to focus on that, okay? Right, I'm gonna try and look at, I wanna be able to see your comments, so please, if I get distracted now and then, it's because I'm trying to read your comments, but otherwise, I think I'm ready to start. Huh? All right, we're good to go. Right, so I'm going to take questions from the November 2023 exams, and you'll see I'm going to try, because a lot of you actually requested for us to do two things, in fact three. I think a lot of the requests that came in were from geometry, right, Euclidean geometry, and as well as trigonometry, right? So I want to be able to go into that. Now, the paper that I have may not be visible, and so that's why I will try to actually use my screen, okay, and I will rewrite some of the questions so that you guys are able to follow on. Otherwise, guys, I'm excited to get started. All right, I am going to start from question 5, which is trigonometry. Let's flow with it and see where we go with it from here. Right, I'm gonna go back to my board. Right, let's go to the very first question, right? So the first question that we've got, okay, says, without the use of a calculator, and please, when they say without the use of a calculator, which means that we need to see the working out. They say, simplify the following expression. to a single trigonometric ratio. Right, so we've got 1 minus the sine of negative theta, the cosine of 90 plus theta, divided by the cos of theta minus 360. Now we are going to, oh, okay, I see Uti people are saying that they can't hear me. So I'm going to try and adjust the mic that I have here. Can you just see if it's clipped on properly?
Let's do that.
Is that good?
Yeah.
Let's see. All right, am I audible? Please just show if you guys can hear me. All right, awesome stuff. All right, I see that many of you are saying you are okay. Right, I'm also trying to stream on my end here. All right, I'm using a phone that I'm not used to. All right, and for some reason, even yesterday, okay, there we go. Right. Okay, I'm able to see your comments, and here are my live audience. Here's my live audience joining me late. Huh? All right, please come onto this side so that I can be able to see you when you have to ask questions. Nah? All right. Okay, so let's go right into it. So they said to us we need to simplify, and I'll be able to see your questions. Okay, I see that you are able to hear now. Okay. Right. Askisi, Lesenho, I see you saying Guti paper 1 through hands. Hopefully paper 2 is going to be nice to us. Askisi, but kuzoluma, I promise you, things will be better. Right, so they say to us 1 minus the sine of minus theta, the cos of 90 plus theta. Now, I want you guys to please note, we are simplifying in this case, right? So we've got 1 minus. Every time we've got a negative angle, how do we deal with a negative angle? We are going to just simply say this is the equivalent of saying the sine of 360, right? You just simply add 360 to it, right? And this is the cosine of 90 plus theta. And this is divided by, now, on this one, because it's not configured in the way that we usually are used to, we can add, and please note, in trig, you can add 360 or subtract 360, and that changes nothing in terms of what the angle looks like. So that is going to be theta minus 360, but I'm now going to add 360 so that that cancels out. So what do I have ultimately? So that's 1 minus. Now remember, I need to go and locate where sine of 360 minus theta is in our Cartesian plane. So please remember, if we use our cast diagram, okay, 360 minus theta is actually in the 4th quadrant. And how is sine in the 4th quadrant? So that's going to be 1 minus. So this is going to be, sine is negative, only cos is positive in the 4th quadrant. That's negative sine of theta. And now I've got the cosine of 90 plus. Now remember that at 90 as well as 270, right, sine and cos will change into what we call our co-ratios, right, our co-functions. So sine becomes cos, but this is 90 plus, which means that this is in the 2nd quadrant. Cos is negative over there, so this is going to be multiplied by negative, because cos is negative in the 2nd quadrant, but we change that to our co-ratio, right? I'm going to remove this so that it doesn't distract us. So that's minus the sine of theta. And what do we ultimately have in this case? So we end up with divided by, remember the minus 360 and the 360 cancel each other out, so we are left with cos of theta. Now ladies and gents, please, I want you to note, this is just reduced into, that's 1 minus negative sign multiplied by negative sign will give us positive sine squared, but multiplied by that negative will give us negative sine squared of theta, and this is divided by the cosine of theta, and as a result, what do we have? We've got cos squared of theta divided by the cos of theta, and in this case, we note that one of the cos theta there, right, will cancel with one of the squares there, right? So what ultimately we are left with cos theta. So remember, they said we must reduce this to one trigonometric ratio. Okay, so we are left with cosine of theta as an answer. School is nice? All right. So a live audience, but you are right. Okay. Right, let's go on to the next question. Right, I want to be quick on this one. Right, I know that it might not be clearly visible to those of you that are watching from online, but I will try my level best to ensure that it becomes, I rewrite it and I explain it. They say, given that cos of 20 is equal to P, right, without the use of a calculator, write each of the following in terms of P. Now let's do that together. So we know that cos of 20 degrees is equal to P, right? I need to always remember to switch this guy off, otherwise this AI stuff gives us some issues. Right, so cos of 20 is P over 1. All right, can I just quickly check, Nje? We're good? All right, if we're good, I'm good. You, okay, thank you. Cool. All right. Right, so cos of 20 is P over 1. So you need to always express this as a ratio, right? Now, if I say to you cos of 20 is P over 1, we now need to remember what does cos, what is the ratio of cos, right? That's going to be X over R. So I need to go and plot this in my Cartesian plane. It's an acute angle, right? It's in the first quadrant. And if I plot this as a triangle, that means that my X value is P, my R value is 1, okay? Now what I need to get is my Y value, and this is where we're going to use our theorem of Pythagoras. So we know that Y squared is equal to R squared minus X squared, right? I'm not going to waste a lot of time, on this one. So this is going to be Y 1 squared minus X is P, that's going to be P squared. So this would be 1 minus P squared. However, remember this is Y squared, right? So what I need to do is get the value of Y. And so you remember that when you take the square root, that becomes plus or minus, but because we're in the first quadrant, we're only going to take the positive value. So that's positive Y minus P squared. Now remember, what they want us to do is to express certain things in terms of that Cartesian plane, right? In terms of those ratios. So now we know that X is 1 minus P squared. So let's quickly do that. Now they say to us, without the use of a calculator, write down each of the following in terms of P. So I want you guys to please note. I need to, because you were not here, because I was talking to the people online. So my focus is on them and less on you. Maramanj, I'm going to shift my focus back to you. Ne? Okay. Right, so we're looking for cos of 200. Okay? So we need to find a way to write this in terms of that angle that we have, which is 20 degrees, right? So there are two things that we need to consider, right? We're either going to consider the reduction formula, right? Our reduction formulae, or we are going to consider special angles. So please note, sometimes we use special angles with, the compound angle formula, right? So we're going to say, in this case, cos of 200
So 5.2.1, what's the cos of 200 in terms of 20? That's the equivalent of saying 180 plus 20, right? But if I reduce this, in which quadrant is this? 180 plus, that's in the third quadrant. How is cosine in the third quadrant? That would be negative, right? So this would be negative cos of 20, right? We already know that cos of 20 is p over 1. So that's x over r. So x is p, r is 1. So this would be negative p. Okay, that's our final answer. What about 5.2.2? So we want to find out sine of negative 70, right? Now there are two ways in which we can do that. Sine of negative 70. All right, quickly, can I go and check if there are no questions? All right, hey guys, I'm using a phone that I'm so not used to, and it's frustrating to navigate, to be honest. Okay, all right, I want to see if okay. Right, hey. Yeah, yeah. Is this how I look? Oh, guys. Okay. Right. I'll try my best to see the questions. And for some reason, I don't know, the phone has kind of switched off the comments. I'll find a way to look at them live. Right. Sine of 70. Right. Of negative 70. So in this case, we've got a negative angle. Nah? Right. It's either one of two things. I know that this is in the fourth quadrant. Right? So you can write this as sine of 360. Remember I said to you, you can always add or subtract 360, right? So this is 360 minus 70. So you know that's in the fourth quadrant. So we know that sine is negative there, right? So sine is negative in the fourth quadrant. So this is going to be negative the sine of 70 degrees, right? But please remember that sine and cos are co-functions of each other, right? So this is going to be minus the sine. Agree with me, this is the same as 90 minus 20. Okay? Right. We've changed absolutely nothing. So that becomes, now remember, sine of 90 minus gives us cos, so that would be negative the cosine of 20. And again, we know what cos is. In this case, that would be minus p over 1. We're good? All right, so far so good. I want to really quickly move from this because there is quite a bit to cover in paper 2. Nah? All right, now the last one, they've given us the sine of 10 degrees. All right, how would we go about this one? The sine of 10 degrees. So that's 5.2.3. Right. Now, how is 10 in relation to 20? Right. So, do you guys agree with me that if I write sine of 10 degrees, right? So, where can I get this? I can say, look, what if I said sine of 20 degrees? Do you agree with it? This is the same as sine of 2 times 10, right? So I'm going to use my double angle formulae in this case, right? So this becomes, and I want you to please note, this is equal to the sine of 20 degrees, but I know in this case, what is the sine of 20 degrees, right? I know that the sine of 20 would give me the square root of, that's p, square root of 1 minus p squared, né? Yeah, square root of 1 minus p squared over 1. Okay? Right, so in this case, I want you to note this entire thing is equal to that. Now, we can write this, and by the way, we can write this as the sine, rather 2 sine of 10, right? Cos of 10, and this is equal to 1 minus p squared. Okay, now another very important thing, guys, just for you to note. So what I've done is I've taken the double angle formula for this guy, okay, and I've said this can be equal to or the equivalent of that particular angle. Now, the very important thing about this is that you must know your relationship between single angles and double angles. Another way in which I could have gone about this one is I could try to say, all right, but how can I write down this, or rather the sine of a double angle, or what we call the sine of a half angle, if I may call it that. Okay, right, so if I say to you I've got sine of 2 theta, okay, and you know that this is actually equal to 2 sine theta cos of theta, what we would actually do is that if I wanted to find out what is the single angle equivalent of this, I can just do some gymnastics, right? Alternatively, what I can then do, I think because I'm trying to just get a little bit of time Nyana into this, so if I say the sine of theta, right, this is also equal to 2 sine of theta over 2, the cosine of theta over 2. So in a sense, you look at it as a half angle. Are you guys with me now? Right. But you can always navigate between double angles as well as single angles. So in this case, they had said to you, okay, sorry, I'm trying to, okay, my pen doesn't want to write anymore. Oops. Okay. All right, sorry, I'm trying to, hey, you know, technology can, okay. All right, guys, my screen has kind of frozen, trying to, all right, let me try to load this question later on. Maybe I'll move on to another question and see if my screen will cooperate better. Okay. Ish. Okay. All right. Sorry, I'll go back to that question later on. Sorry about that. Okay, so in this case, let me just give you, for some reason, I don't know why is this thing giving me a bit of issues now. Okay, right, let me go into this one. They say to us, determine, and the thing about Matric Buffet is it's really not exciting. I don't know about you. It's just applying the rules. So they've given us here, we've got cos. All right. So they've given us the cosine of a plus 55, the cos of a plus 10, plus, okay, I'm trying to fill out as much as possible so that it's visible. So we've got cos of a plus 55, cos of a plus 10, plus the sine of a plus 55, sine of a plus 10. So firstly, what I want you to recognize is that this is a reduction compound angle formula, right? So if you notice there, we remember that the sine, or rather the cos of a plus b is equal to cos a, cos b, right? And note, when I write it down, it always changes sign, right? Inside the bracket. So this is minus sine A, sine B. So meaning, if I have cos of A minus B, that is the one that will change into a positive. So what I'm going to do, I see here that my first angle is A plus 55. My second angle is A plus 10, right? So let's try and rewrite it in that format. Okay, so I'm gonna have cos, my A value is A plus 55 minus, now please remember to put it in brackets, né? So it's A plus 55 minus, that's going to be A plus 10. Right. And so what does this give us? Inside our big bracket there, I've got A plus 55 minus A. Remember that the negative multiplies into the bracket, né? So that's going to be A minus A, that's going to be 0, and that's going to be 55 minus 10, so we end up with the cos of 45. And you know from your special angles in this case, that cos of 45, you can either write it as 1 over root 2, or you can say this is root 2 over 2. Okay, right, beautiful stuff. I want us to quickly, as I said, because we've got quite a bit to cover, a bit of ground to cover, I'm going to move on from that one. So we've got to 5.4 in this case. Right, again, I'm going to try and log in and see if there are any questions. With our online community. Right. Okay. Ubusisiwe says, he's fast. I'm trying, Busisiwe, to be as slow as possible, but the problem is, the problem is, I'm trying to get as much as possible before 2 o'clock, né? Because our live is going to end then. So on 5.4, so they've given us there, right, the equation cos of 2x plus the sine of 2x minus cos squared of x divided by the sine of x minus 2 cos x. So I'm rewriting it so that you can be able to see it properly, nah? Especially for those of you that are online. And they said this is equal to negative sine of x. Sorry, I'm going to try and squeeze it in there. Right, so this is equal to negative the sine of x. There's a little bit of a reflection here, and I don't know if I like it. But yeah, there's not much that I can do about it right now. I hope that this isn't too bad. Right, so the first thing that they asked us to do was to prove the above identity, okay? So remember guys, when we are proving identities, we work with the left-hand side and the right-hand side separately. So the one thing that I want you to always be mindful of, so what I normally do is just draw a vertical line like that, okay? So that I can have the left-hand side separately and the right-hand side. Now remember, on the right-hand side, I've got minus sine x. So right now, I'm going to work with the left-hand side. So the left-hand side is cos 2x plus sine 2x minus cos squared of x. This is divided by the sine of x minus 2 cos x. Now, if you note there, I've got cos of a double angle. Now remember what you've got 3 equivalents for cos, ne? For cos of a double angle. And we never really know which one to take, but I always say to you, check what you have, right? If I look at my denominator, do you see what on my denominator I've got sine and cos? Can we then make a case for changing it to cos and sine, right? So then what's the cos of a double angle? That's cos squared of x minus sine squared of x. Now guys, I want you to please note, why did I choose this one? I specifically chose this one because I looked at my denominator, okay? I looked at what I'm given in the denominator, and in my denominator, in this case, I had minus sine squared of x, right? I mean, I had sine and cos, right? So I chose this one so that at least it would kind of reflect what is already there. Now, sine of a double angle, we know what it is, né? So sine of a double angle, that's going to be 2 sine x cos x, and this is going to be minus cos squared of x. Are you guys with me now? Right, and this is divided by sine of x minus 2 cos x. Ish, manje bathe I'm going too fast, and now I'm trying to, actually I should be going faster, mara ish, I'm trying to navigate between the two. Now do you see what happens in this case? The cos squared of x minus cos squared of x and cos squared of x will cancel each other out. And now I'm left with minus sine squared of x plus 2 sine x cos x. At the denominator, I still have the same thing. I couldn't change it to anything. That's 2 cos of x. Now notice in this case, you've got two terms on the numerator. And both terms have got a common factor. What is that common factor? Well, that's sine x. But if I look at that, I want that sine x to actually give me another bracket inside that would cancel with the denominator. And so I will take out the negative as well, right? So that's negative sine x into, so that will be negative sine x multiplied by what will give me negative sine squared of x. That will be sine x. And now that's minus, in this case, what is left? That's 2 cos of x. And notice in this case, that's exactly what we have in the denominator, sine x minus 2 cos x. And so what I notice is that this guy at the denominator can cancel out with the one at the numerator, and what do we have left? Minus sine x over 1. And so that's exactly what we were trying to get. So what can I say, guys? Left hand side is equal to right hand side. Okay. All right. Okay. So left-hand side is equal to right-hand side. Now the next question. We've proven the identity. They say to us, determine the value of cos 2x. Okay, let me try and maximize it. They say determine the value of cos 2x plus sine 2x minus cos squared of x. Do you see what that looks like our denominator? Our numerator rather, right? And then they said minus sine squared of x plus 6 sine x cos x. Can I ask the people here in class, what do you think we can do here? Let's try and get this guy. Okay? Ah, man. This thing can really be frustrating. Okay, let's try to get this guy to look like what we have in the numerator. I mean, in the first example, right? Now, if you look at this, our numerators are already the same. Do you guys agree? Right? So our numerators are exactly the same. Let me try and factorize the denominator. Do you see that? Right. So I'm going to write this. Can I just change the color of it? I hope that it's visible for the people that are online. Né? Right. So what I'm doing is I'm rewriting what I have over there so that it looks like what we had. So the numerator stays the same. So cos of 2x plus sine 2x minus cos squared of x. But what am I going to do? Let's factorize this guy. What does it factorize to? It becomes minus 3 sine x into, that becomes sine x minus 2 cos x. Do you guys agree? Right. So I've factorized this expression at the denominator, taking out negative 3 sine x at the denominator. Now, do you notice that we still have that expression that we had on the right hand side here? Right? What's the only difference? The negative 3 sine x. So we still have that entire, and I'm going to mark it in red. This entire expression over here is exactly what we had on that other expression, right? So what was that equal to? That was equal to negative sine x. So that means I can replace that entire red part with negative sine x. Are you guys with me? And this is negative sine x divided by negative 3, because we're still dividing by this entire thing. So this is negative 3 sine x. And I'm sure you can see where we are going with this. Nah? All right? Sine x and sine x will cancel out. And in this case, I've got negative 1 over 3, which will give us 1 over 3. So the value of this is simply 1 over 3. Okay. Are there any questions? Do you guys want to ask? Yeah, right. Okay. Right. For the people that are online, Jadine is still saying I'm too fast. Oh, Nkosi. Jadine, Anity, you can rewatch. I promise I'm going to save this live, and you can rewatch this live again later, as slow as possible. But I promise that I'm going to save it. Okay. Right. I hope that you don't mind that. Because we're trying to cover as much ground as possible. Okay. Right, now let me go to the next portion, which is 5.5. So in 5.5, they've given us 3 tan of 4x right, minus 2 cos of 4x. And they say without the use of a calculator, without using a calculator, show that sine of 4x is equal to negative 0.5 is the only solution to the above equation. Right, so what are they asking us to do? Essentially, they are saying simplify. 310 of 4x will be negative 2 cos of 4x. All right? So let's try and see if we can simplify this and prove what they've asked us to do. Okay, right. So remember, when I'm dealing with equations, in this case, I've got cos and I've got 10. What am I going to do? Change everything into sine and cos, right? So in this case, I've got 3 sine 4x divided by cos 4x. And this is equal to negative 2 cos of 4x. Now notice, I can actually write this, as a fraction, right? Where I cross multiply. So if I cross multiply in this case, I've got 3 sine of 4x times 1, which is equal to negative 2 times cos 4x times 4 cos 4x. So what do I have? I'll have negative 2 cos squared of 4x. Makes sense, guys, ne? Right. Now, please, I want you to note, in this case, we're trying to simplify as much as possible. So what we're going to do, I've got sine x here that I can't do anything about. Okay? So what am I going to introduce? The square identity, right? So remember that whenever we've got cos squared of x, or of any angle of A, right, that can be written as 1 minus the sine squared of A, right? So can I not use that over there? I know that when I've got cos squared of any angle, right, so this would be 3 sine of 4x. This would be negative 2 into 1 minus sine squared of 4x. Okay. Prof. Len says, I'm a teacher from Kenya. Really appreciating your work. Thank you so much. I really, really appreciate that. That's a really kind comment. If you can, please just reach out to me via my email address, info@mlungisinkosi.co.za. Let's see if we can do a collaboration at some point. Okay, right. This is me becoming a YouTuber now. Okay, so, right, so let's go for it. So we've got 3 sine of 4x. Now let's transpose, or rather let's first try. So that's negative 2 plus 2 sine squared of 4x. Okay, and now we see we've got a quadratic equation, né? Right, let's write that as a quadratic equation. So I'm going to take the 3 sine 4x to the other side. So that's 2 sine squared of 4x. Okay, that's minus 3 sine of 4x. And that's minus 2. I'm writing it as a quadratic equation. So this is equal to 0. All I did was to take this guy to the other side. Now I've got sine squared, and I've got another bracket there which has sine. So if we factorize this, and guys, please, I want you to invest in knowing how to factorize. What will it give me? 2 sine of 4x, okay? And I know that this will be multiplied by sine of 4x. Now I want you to note I've got 3 sine of 4x here, so which means that 2 will come onto that side, so that you've got 4 sine of 4x, right? But that needs to be negative, and so that will be 1 over there. Now I want you to notice something here. We probably have two solutions, but we need to check. Are those actually solutions that we can use? So I've got sine of 4x will be equal to what? Negative 1 over 2. Okay? Or sine of 4x is equal to 2. Now please, I want you to note, guys, there's no solution to this. Why? Because the sine graph can only have a maximum of 1 and a minimum of negative 1, right? Especially in the case where our amplitude is 1, right? So in this case, there is no solution. If you try to use your calculator, you'll see that it will actually show you that there's a maths error, right? So in this case, there is no solution. And that is why this question said to you, show that sine of 4x is equal to negative 0.5 is the only solution, right? So sine of 4x is equal to negative a half. This is the only solution. Does that make sense, guys? All right, beautiful stuff. So the next part, I'm sure they are going to ask us to find the general formula, and now they say to you hence. So if you couldn't work out the first part, you're more than welcome to then use that solution to find the general formula. The general solution, right? So they said find the general solution of this entire thing, but we've already simplified it, isn't it? Okay, to sine of 4x is equal to negative 0.5. So in this case, I'm going to say, so sine of 4x is negative 0.5. So that means that 4x is equal to the arcsine of negative 0.5. Now, I want to pause a little bit here. Guys, there are two methods in which you can work this out. Some of you may prefer to use reference angle, right? I prefer to use the sine of the angle and 180 minus the angle, right? Both methods are correct, okay? So I'm gonna do the 180 minus the angle. So which means 4x is equal to the arcsine of 0.5, right? If you say shift the sign of 0.5, negative 0.5 rather, right? You get negative 30, right? So that's negative 30 plus K 360, and please remember that K is an element of integers. Now remember, this is not the only solution. What's the other solution? That 4x, okay, I'm going to write it here, is going to be 180 minus negative 30. So you always take 180 minus, okay? I don't have the time to show you why I'm saying that, okay? I do that actually in my videos when I walk you through this. So that's 180 minus the angle, which is minus 30, plus K 360, where again, K is an element of integers. Now, all that's left for us to do is to try and solve. We're going to divide by 4 on either side. So what are we left with? X is equal to 30 divided by 4. That will give me negative 7.5. But in this case, please note, this is plus K 90. Okay, right, we divide that by 4, and K is an element of integers. The other angle, we've got 4x is 180 minus a negative 30, which gives us 210 plus K 360. And if we divide by 4 on either side, X will be equal to 52.5, right? 52.5 plus K, plus K 90 as well. And please, guys, always remember to say that k is an element of integers. Are we good now? Right. I want to just, before I move on from this section, given that my pen is now behaving, right, if we go back to that question that we had, right, sine of 10 degrees. Okay, I want to just quickly go into that. So, to be honest with you, I almost overcomplicated it. Nah? I think the easiest way to go about it is to use, so remember I said to you, you can use reduction formula or you can use compound angles, right? Okay, using special angles, right? So another way that you could have done it is just to simply say, this is the sine of 30 in relation to 10 degrees. 30 minus 20 is still equal to 10, isn't it? Right, so I've changed absolutely nothing. But we know the equivalent of sine, okay? So we know the equivalent of sine. So remember that sine of A plus B will give us sine A cos B plus cos A sine B. Sorry, I don't have much space there. So this would be equal to the sine of 30 cos 20 minus, so remember that it retains its sign, minus the cos of 30 sine of 20. Okay, that would be the easiest way without using half angles. Yeah, I think that was really going to complicate it a little bit. So if you know that, guys, you need to remember your special angles, particularly for those of you that are going to write the NBT exams. It's important for you to remember your special angles. Right, so we've got sine of 30 degrees, which is 1 over 2. But you remember we had cos of 20, which was p over 1, right? Minus cos 30, that's root 3 over 2. And sine 20, which would be square root of 1 minus p squared, again over 1. R is 1, isn't it? Right. And you'll notice that on the left-hand side, rather, on this equation here, you end up with p over 2 minus the square root of, now I can write this as just 1 square root, 3 into 1 minus p squared. And this is divided by 2. And so ultimately, what do I have? Right, my denominators are the same, so I can just simply add the numerators. So I've got p minus the square root of 3 into 1 minus p squared divided by 2. I hope for those of you that are online that this is visible, right? I think from where I'm looking, I think it just looks visible. So I think we are good in that regard. Okay, right. Okay, can I just check quickly? Good afternoon, Malume. Can you please do at least 5 June exam papers for maths and physical science? All right. Okay, I'll see. Let's see how much time we've got at the end. Let's see how much time we've got at the end, and let's see if we can add some more questions to it. The thing is, for me to be able to load those questions, that's why I prefer you give me questions prior. Otherwise, then I have to go to another source, get the question paper, and then bring it on to here. Nah? Okay, so I'm going to try at the end, though. Let's see how that works out. Okay, right. So we are done with that. So I want us to go to the to trig graphs. Hey. Right. So we're going to try it by all means, to try and see where the issues are in terms of trig graphs. So they give us there, in the diagram below, we've got f of x, which is 10 of x minus 45. Sorry if you can't see it clearly, but I will write it down properly. So they say it's drawn between negative 90 and 180. Okay, right, now let's go for it. They said to us, write down the period of the graph. Now please, I want you to note, what is the period? So whenever you're looking at the period of a graph, you always go on to here, right? And first look at the frequency, right? Now the frequency will always be determined by the coefficient of your x term, right? So what is the coefficient of our x term here? It's 1. Are you guys with me now? Right. So the thing about the period of a 10 graph, now please, I want you guys to remember this. For the sine and the cos graph, the period, right, for a complete wave, it's always 360 if our frequency is 1. So if the coefficient of x is 1, then in that case it means that our frequency is 1. But for the 10 graph, right, remember it repeats at every 180-degree cycle. So the period here, because our frequency is 1, our period will be 180 divided by the frequency, which is 1. So it is 180. Okay, I hope that's clear, guys. Make sense? Okay, right. So if our frequency was 2, then it would have been 180 divided by 2. Okay, right. Let's go to the next one quickly. 6.2. Now they say to us, draw the graph of negative cos 2x. Now guys, there's an easier way to draw this using our calculators. Okay, right. You just put in the equation, you plot, in this case, because you are dealing with the graph of cos of 2x, your frequency is 2, right? Which means that it's a more compressed graph. Okay, so what I want you to do is that your steps, when you put it in your calculator, you're always going to take the steps of 45 in this case. So you always say 90 divided by whatever the frequency is. Okay, so your steps are going to be 45 in your calculator. Okay, sorry, I don't have a Casio calculator here, but I would have, but yeah, then the thing is, how do I show it there? You see, navigating with that. And the thing is, the calculator that I'm using here doesn't use the same process, which kind of defeats the purpose. But what I'm going to do is, let me draw what the graph is going to look like. So my normal cos graph, remember, I reference from my normal cos graph, okay? And my normal cos graph looks something like this, okay? It's going to start at 1, all right? And now, because my steps are 45, it's going to, so it would have been, remember, this is cos of, the cos of 2x. But remember, this one has got negative in it, right? So the graph of cos of 2x would have looked something like this. Okay? And if I continue on to the next side, it would have looked something like the dotted line over there. But I need to flip it around. Okay, so I'm gonna try. I'm gonna make it a little bit thicker so that it's properly visible. And I'm gonna draw it in a different color. Right, everything that's positive is going to be negative. So my graph Right. So that's my graph for the cosine of, negative cosine of 2x. Are we all together, guys? Is that right? Yes, ma'am.
We put like on the starting angle, we use the degrees.
Do we use?
The degrees that are on the x-axis.
Yes. So remember, you still use the same interval that is given to you. I don't know. Is that what you're asking? Okay. Yes. You still adhere to the same interval. And remember, even when they asked the question, they did say between negative 90 and 180. So yes, you still use the same interval. Okay. Right. They probably would have given you this graph onto your booklet, your answer sheet, right? So all that you need to do is just use that answer sheet to draw the other graph. Okay, right? Because I don't have it, I'll draw it right there. Now let's go to the next portion. They say to you, write down the range of G. So remember, G is your new graph, right? So what's the maximum and the minimum in that case? Okay, my maximum is 1, my minimum is negative 1. Okay, right. So in this case, okay, so it's drawn over there. So we're looking at 6.3. Nah? So what is my range? Y is an element of negative 1 to 1. And please remember, you always write it from minimum to maximum. Okay, all the time. Happy days. It's good, it's nice. Right. And then let's go to the next one. They say the graph is, the graph of G, right, is shifted 45 degrees to the left. Now, guys, I want you to remember, anytime I'm shifting a graph to the left, right, what I will do is I will always say plus. And I know it's counterintuitive. I'm shifting it to the left, which should be on the negative side, but I always say plus, right? So which means in my equation or in my formula, I'm going to say plus 45. If they were saying I'm shifting it to the right, I'm shifting it to the positive side, but I'm going to say minus 45. Okay. And the reason for that is that it's not the graph that's shifting, it's actually the axes that are shifting. Okay. Right. Now they say to us it's shifted to the left from the graph of H, right? Write down the equation of H in its simplest form. Now remember, the graph of, sorry. The graph of H, the graph of H is the graph of G shifted by 45 units. So, but in its simplest form, right? So that's 6.4. So that would mean that H of X would be equal to negative cos. Now remember, what did I have? I had 2x. And I said we are shifting to the left. So what am I doing? Right, plus 45. Okay. What is that? Is it? Naman. It's negative cos of 2x. Okay, right. It's negative cos of 2x, but now all we are doing is adding 45. Okay, right. Now they did say to you you should write it down in the simplest form, right? Let's see. Can we write it as? No, I'm going to leave it like that. Okay, I'm going to leave it like that. Right. I was just thinking of simplifying it into the compound angle, but it's just going to complicate it. Right. So that is how we are going to write it down. Now, guys, I want you to please note in this case, I do think that there is a simpler form though. Yeah, I'll think about it, but I think there is a simpler form. Okay. Right. Now they say to us, use the graph Do you see? Right? So meaning that in your booklet, they would have actually drawn the graph of f, right? You also have the graph of g to determine the values of x in the interval negative 90 to 90. So they are saying focus from this and, okay, there it is again. Okay, focus from here to there. Do you see? We're not interested in anything beyond, right? So, now, firstly, what's happening? Where f of x is greater than 1. Now, please, guys, let's look at the graph of f of x, right? In that interval, where is the where's the 10 graph greater than 1? Do you agree with me that between negative 90 and 45, right? Do you see? It's greater than 1 over there, right? So I'm going to just indicate them with red. So between negative 90, right, to negative 45. Do you see it? How guys talk to me? Never? Right. Where else does it do so? Right. Between 90 and 135, but that's outside of the interval they've given us. Do you see? Because Bateni, between negative 90 to 90. So we are focusing here. Right? So where's our 10 graph greater than 1? It's only between this interval over here. Right? Now, my question is, are we going to include or exclude negative 90? They said greater than 1. At negative 90, it's equal to 1. Does that make sense? So I'm going to exclude that value. So notice they said greater than, not greater than, or equal to 1. Okay? So for 6.5.1, I'm going to say x is an element of, I'm going to show you how to write this in two ways. Negative 90 up until negative 45. Negative 45, is included. No, it's excluded because we've got an asymptote over there, right? So that would be excluded because it's undefined, essentially, at negative 45. Okay, right. Another way that I could have written this is x is greater than negative 90 and less than negative 45. That's another way that we could have expressed that same solution. Okay. Happy days, ne, guys? All right. All right. Okay. All right. Ntombe, you said you can't see the question clearly. I'm trying my level best. So this is from the 2023 November exam. Okay. So you can try to source that question paper so that you can be able to see it. Maybe in future what we'll do is that we'll provide you with a link for the question paper that we are working from. Ne? Okay, so that it becomes easier. All right, finally, now they say to you, use the graphs to determine the value of x between negative 90 and 90. Right, now, what are they saying? Where 2 cos of 2x minus 1 is greater than 0. So, what does this look like? What does that look like? What does that look like? It looks like the graph that we had, the negative cos of x, and negative cos of 2x, the graph of g, isn't it? Can we try, let's manipulate it so that it looks like it, right? So I'm going to say, well, okay, let me, let's say, in this case, cos of 2x, okay, 2 cos of 2x is greater than 1. And I'm going to divide both sides by 2. Okay? So I end up with cos 2x is greater than 1 over 2. But remember, our graph G was negative cos of 2x. So let's multiply by negative. Now remember, when you multiply by negative, the inequality changes sign, right? So that would be minus the cosine of 2x, and now this would be less than negative 1 over 2. Does it make sense, guys? Right. So, where is that graph of G less than negative 1 over 2? Can you see that? So, essentially what they are asking is, where is G of x less than negative 1 over 2? So where is it below negative 1 over 2? Let's go to that graph. Okay. So if I look at that graph, firstly, where is negative 1 over 2? That's over there. Can you see it? Right? Let me just use a different color. So it's 0.5. I just removed my graph. Okay, so it's 0.5 over there. So I'm trying to indicate. So it's 0.5, negative 0.5 over there, right? So what's the solution, Gonja? Where is it equal to 0.5? Let's find that solution. Eh? Okay. Negative cos of 2x is equal to negative 0.5. Okay. So negative times a negative would give me a positive. So cos 2x is equal to positive 0.5. And then I've got 2x is equal to the arc cosine of 0.5. And in this case, if I divide, if I've got 2x, this would give me, where is cos 0.5? That's at 60, plus and minus 60, isn't it? Okay, so that's plus and minus 60, plus K360, of course. And if I divide by 2, what does that give me? That's plus or minus 30 degrees. Correct? All right. So, in this case, where is that cos graph equal to less than negative a half? So, that would be between negative 30 and positive 30. Does that make sense? And because they said below less than, I'm not going to include that interval. Ne? So that's 6.5 rather, 6.5.2. That would be x is an element of negative 30 excluded to 30. Okay. Or you can say x is greater than negative 30 and less than 30. All right. Yebo.
Can you scroll up?
Scroll up, yes.
Yeah. So I wanted to ask, okay, you are like when you did when you changed the question you had two questions.
Where I had Gonya, where did I choose that? Oh, I did it on the actual thing, yeah.
And then I wanted to ask, how were we able to just divide by -1? Which conditions allow us to just divide by -1?
Which condition? Mathematics allows us to. So remember, what was I trying to achieve? Why did I divide by -1? This equation here unless you are trying to reinvent the wheel, you would end up having to solve this. We don't want to do that. We want to read off the solution from the graph. You understand? So I'm trying to manipulate what I have so that it reflects what the graph looks like. So I'm taking this and I'm trying by all means, on the left-hand side, I should end up with one of my graphs. You get what I'm saying, né? Right? So as a result, then you would end up with that. Okay? Happy days. Sure. All right. I still do think, Uti, there was a way in which I could simplify that equation. Anyone who has an idea? So if I wrote this as, if I took out, yes. Actually, there is. Let me show you. If I took out 2 as my common factor, so h of x would be minus the cos of, if I took out 2, what am I left with? X plus, now be careful. In this case, no. If I took out 2, oh, no. So I was thinking of being left with x plus 90. Let me see. Won't there?
I'm saying the way that you put it at first, if you took out the 2, the 2 was going to multiply it by 45, and then you'd get a 90.
Yep. No. So you're saying if I, yeah?
At first, the way that you wrote it,
Yeah.
you took out a 2.
Yes.
And if you're taking out the 2, the 2 is going to multiply everything inside.
Yeah, but then it becomes 45 divided by 2 is 22.5. Yeah, so I'm actually trying to find a way yokuthi ngibhale as a not in compound angular form, but as a reduction formula, right? Yeah, okay. Yeah, if I can't find it now, it's okay. We'll find a way later. Okay, right. I want to quickly, guys, go into. So I've done this part. One of the things that were requested, which were kind of an issue, were also 3D trig, right? So I want to quickly run there, if it's possible, and then let's get into Euclidean geometry. Let me do this. Right. Okay. Now, for those of you that are watching this online, please, I want you to remember this. When you are working with a 3D trig, there are 2 things that you need to remember, right? You need to know, firstly, the relationship between triangles. So whenever you've got a triangle, let's say, here it is, I've got a triangle. Right, there are 2 things. There's the sine formula, sine b over b, right? Now you use this whenever you've got 2 sides and then 2 angles and a side, or if you've got 2 angles and 2 sides, or whatever the case may be, right? So the only time when you are going to use the cosine formula, right? That is a squared is equal to b squared plus c squared minus 2bc, the cos of angle A. This is only when you've got 2 sides and an included angle. Right, I'm going to try and just make my writing a little bit bigger nyana so that it's, yeah, there we go. Right, now let's start with the diagram. We're going to start on the triangle that has the most information. They say to us, in the diagram we've got A, B, and C, which are points in the same horizontal plane, right? So horizontal plane suggests this is on the floor, okay? And I like the fact, Yoguti, sometimes they shade it for you. If they haven't, please learn to shade it for yourself, okay? Right, and then they say to us, These are points on the same plane. D is a point directly above C. So which means CD must be a vertical line. Makes sense, no? Right. Now they say to us CD, or rather DC, is perpendicular to AC. So meaning, if I look at that triangle over here, which is ACD, what type of a triangle is that? It's a 90-degree right-angled triangle. Beautiful stuff. And then they also tell me the same thing. DC and BC are parallel to each other. So that must be a 90-degree triangle. Sorry guys, I hope that you're able to see this. How would you determine the maximum and minimum value of in a trig graph? Okay. All right. So, Ntokozo, I see your question. Okay. Hi, Ntokozo. All right. How would you determine the maximum and the minimum value? You just look at your graph in this case and look at, depending on which type of graph it is, right? For your 10 graph, it's undefined. Right, but for the cos and the sine graph, you would look at your minimum value, which is the lowest point that your graph has, and your highest point that your graph has. Okay, that is in terms of your minimum and your maximum. Now, guys, let's go back to this question. All right. Now they say to you, calculate the length of AC. So note, if I want to find the length of AC, I will have to start on the triangle that has the most information. Which triangle is that? Right? Notice triangle ADC. Do you see that? I've got a side, I've got an angle. In fact, I've got two angles because I also have that 90-degree angle. Right? So you always start with the triangle with the most information. And guys, I can promise you, right? It always works out that way. You start with the one that has the most information. And what you do is you go to find a common side with another triangle. Now, can I check? Right? If I go to triangle ADC, do you see what side AC is a common side to triangle ABC? Right. So let's start there. So even if they didn't guide you into the question, what you simply do is you start with the side that's always common. Firstly, triangle with the most information, side which is common to one side, to another in the triangle, right? So let's look for AC. So in this case, I've got a 90-degree triangle. I've got an angle there, 30 degrees. So AC, do you agree with me, is the adjacent side, right, in that triangle? And what about this side that I'm given? It's the hypotenuse, right? Now, please, you state which triangle you are going to work from, right? I am going to say, all right, so if I look at that, in triangle ADC, right? Adjacent over hypotenuse, which trig ratio is that? That's the cos, right? So the cosine of 30 degrees would be equal to adjacent, which is AC, divided by my hypotenuse, which is AD. Now note, cos of 30, AC is the side I'm looking for, and AD is equal to 20 degrees. Are we good, guys? Right, so if I cross multiply, AC would be equal to 20 cos 30. What does that give us? Okay, maybe just to avoid maybe rounding off at this stage, né? I'm going to represent it as just 20.
Or you can write it in set form.
Excuse me?
I was going to say you can write it in
Yeah, you can write it in set form. So remember, cos 30 is root 3 over 2, né? Right, 20 divided by 2 gives me 10. So this would be 10 square root of 3. Now remember guys, here you are dealing with dimensions. So this would be units. Okay. Right, unless it's given to you in centimeters or in millimeters. So I'm just going to represent it here as units. So the size of AC would be equal to 10 root 3 units. Nothing wrong if you decided to represent it in decimal form. Okay, right. And then what are they saying to me? Let's find AB. Now you'll always see, once you've found your common side, it then gives you information about the next triangle, right? So do you see with Manja, you've got another triangle, which is ABC. You've got the side 10 root 3. You've got the other side, which is BC. And what do you notice? You've got the included angle. And every time you find yourself with two sides and an included angle, then you are going to use the cosine rule. Okay, right. Guys, I'm scrambling Yana for space here. I hope that you'll be able to see. So I am going to say AB squared is equal to, it's the other two sides, BC squared plus AC squared minus 2 times the very two sides that you have on the right hand side, BC times AC, the cos of the included angle. And what is our included angle? It's angle C, right? Oh, sorry, I should have actually said in triangle ABC. Please always state which triangle you are working from. Okay. Right. So now, what do I have? Let's substitute there. So I've got 8 squared plus 10 root 3 all squared minus 2 times 8 times 10 root 3 cos of 100. And please guys, don't waste time here. We just simply put that in our calculator, né? Okay. Sorry, my calculator is making a lot of noise. I hope it's not irritating. So that's 8 squared plus 10 root 3 squared minus 2 times 8 times 10 root 3. You got it? Multiplied by the cos of 100. Okay, I got 20.3. Is that what you guys got? Okay. So AB is 20.3. And please remember, this is a side, so therefore it must be units. Please remember to take the square root, né? Because remember, we started as AB squared, so we take the square root right at the end so that you get the value of AB. All right. So once you've got two sides and an included angle, then you know, straight up, you're going to use the cosine rule, right? And then finally, they say to us, if it is further given that angle ABD, let's see, where's ABD? ABD. Okay, so now I want you to please be very careful, nah? So you are now looking at this triangle over here. At this triangle over here. Do you guys see it? Right. So they give you the size of this angle over here. Huh? Sorry, they said ABD, sorry. So that's ABD. So it's this angle over here, sorry. That's 73.4. Yes, thank you for that. Right, so that's 73.4. Okay? So you've got an angle 73.4 over there, right? They want you to calculate the size of angle ADB. Size of ADB. So which means we're looking for the size of this angle here. Are you guys with me? But let's check. What are we given? We already have AB. Until we calculated this, it's 20.3. Right? Units, right? And then what else do we have? We've got this side here, which is 20 degrees. 20 units rather, which is AD. Okay? And we've got one angle. So note in this case, you don't have two sides and an included angle, so we can use the sine rule. I'm looking for this angle, I've got the opposite side, right? I've got the angle, I also have the opposite side. So I'm going to say in triangle ADB, the sine, Gonja, what am I looking for? ADB, no? Right, so the sine of ADB, right, which is that angle there, divided by the side that is opposite that angle, which is AB. Do you see it? Is equal to the sine. What is the angle opposite that, what is the other angle that we have? The angle that's given, which is ABD. ABD. The side opposite that angle would be AD. Are we good? Right, and all that we simply do, sine of ADB, I hope it's still visible, will give us, if I multiply that in, it's AB. Gonya, what's the size of AB? 20.3, nah? Sorry, I'm struggling for space here. 20.3, the sine of 73.4 divided by the other side, which is 20 degrees. Right, so let's do that. So that's 20.3, the sine of 73.4, and we divide that by 20. I get 0.972, but then we are looking for the angle, so we're going to say shift the sign of our answer, and I get angle ADB to be equal to 76.5. Yes? Is not make sure. You didn't put in there? With the whole decimal. What did you get for your angle? Okay. I don't know. I could be wrong. Did you got the same 76 point? Okay. Please check. Please check. I don't think 76.58. Please, can someone online please check? Okay, yeah. All right, I can see that you say you got the same answer. All right. I see some of you are commenting on yesterday's paper still. Guys, like, just get out of that funk. Okay. Right. Please, just make sure, Njegoti, right now you focus on paper 2 and you avoid distractions. Okay. Right. So that's how we are going to quickly look at this particular section. Okay, right. I hope that it's been clear. Nishap. All right. Okay. Right. I want us to quickly run into Euclidean geometry. Sure. Let's try and do as much as we possibly can. All right, and we'll see if we can end with the proportionality theorem. Okay, just see if we can apply that. And by the way, here's the thing I want to also give you advice. Maybe let me leave that for the end. Nah? Yeah, let me leave that for the end. Okay, right. In the diagram, we've got center O. Please, guys, Euclidean geometry. Remember, you don't only focus on the 9 theorems, ESGA grade 11, right? But you also need to remember, we've got the theorems that have to do with straight lines, right? And the one that you guys sometimes forget, especially when it comes to triangles, the exterior angles on a triangle, right, would be the sum of the interior opposite angles. Also very important for you to note is that, you see, for instance, immediately when they tell me that I've got a center, the first thing that I do is mark my radii. Okay, right, so let's start with that. They say O is the center. I don't know what the question is, but the first thing that I'm going to do is mark my radii. Why does that help? Because can you already see I've got a triangle there, an isosceles triangle, right? And once you've got that isosceles triangle, you know in this case that it means that angle K is equal to angle T. Right? I don't know if we're going to use that. Okay? Right? I haven't done this question before. So in this case, but I know it might be of help, right? Right. So now they say to us KT and L are points in the circle. We've got KT, we've got TL, we've got KL, we've got OK that are drawn. Okay, that's just information. All right. OT intersects KL. Now, please, I want you to be very careful. Once they tell you that lines intersect, either one of 3 things. Number 1, it means that you might either have vertically opposite angles, or it might be that you've got exterior angles, right? So magnetic exterior angles, it might be that we're talking about exterior angles of a triangle, or we might have exterior angle of a cyclic quad, right? But I want you to note in this case, every time we've got an intersection, we might actually be looking at that. Now, here's the posa yama posa. ST is a tangent. Okay? Immediately when they say tangent, we might look out for the 10-chord theorem, right? Sometimes, of course, there are those 2, but I can most certainly tell you with the most popular of the 3 theorems that have to do with tangents is the 10-chord theorem. Okay, right. I'm not saying that they will not examine the others, but I'm just saying that it is the most popular. Right, now let's quickly go for it. They say STK is 36. So what I'm going to do is let's try and work within the triangles. Is that okay? I mean, within the angles, right? So I've got a tangent over there, right? And here is my chord. The angle between the tangent and the chord is equal to the angle on the opposite side of that chord. What does that already tell me? That this guy here is 36 degrees, 10 chord. The reason why you might not be able to see it well is because the tangent is on the other side. So sometimes if it's worth it, just flip the diagram a bit. Okay, yeah. So unfortunately, in my case, I don't have the luxury of being able to flip around this diagram. Né? But in your case, I mean, you're sitting in your exam, it's your script. Change it around, right? And then you'll see, oh, okay, there's 10 chord. So it means angle L must be equal to T1. But I'm also seeing something. Can you see it? I'm also seeing angle O there. What would be the size of angle O? Right, it's twice the angle L. So it's 36 times 2. So this guy must be 72 degrees. Angle at center is twice angle at circumference. Okay. But we've got an isosceles triangle. We know T2 is equal to K. So because those two are equal, what's 180 minus 72? That would give us 108, ne? And 108 divided by 2 would be 54. You saw 10? Yes, absolutely. Absolutely. There was another way, right? And that's a beautiful thing about T, Elon. So you saw, Guti, we've got 10 perpendicular to radius, right? So which means that's 90 degrees, right? So you can say that T1 plus T2 is 90, meaning that T2 is 90 minus 36. Very good. Very good. 90 minus 36, which would also give you 54. Okay. Right. So either way, we get there. Now let's see, what questions did they ask us? They said, firstly, find out what T2 is. Hey, it's a good thing that you told us that. Ne? Yeah, because then we might have taken the long way around. So they said T2. So I'm going to say T1 plus T2. And please, guys, show Guti their angles. Ne? So T1 plus T2 is equal to 90. Konje, what's the reason? That's 10 perpendicular to radius. Okay? Right. But we know that T1 is 36. So in this case, it means that T2 will be 90 minus 36, which is equal to 54. See right? Good stuff. The next one, they said find the angle L. Did you see what we found it already? Okay, so how do we find angle L? L will be equal to T1, angle T1, right? Which is 36 degrees. Konje, why is that? It's the 10 chord theorem. Not bad, right? And then what about KOT? KOT, which one is that? Oh, KOT, we already found it, nah? This guy here. So, for C, KOT is equal to 2 times angle L, and that's because angle at center is equal to 2 times angle at circumference. Are we good, guys? All right. And then finally, so which means that KOT would be equal to 2 times 36, and that's equal to 72 degrees. Okay, right. For all of you online, I hope that you are able to see this. All right. Shemunobushe says she's losing hope. Please, Nobushe, don't lose hope, okay? Okay, and the Bulele says, I forgot, Malum, I think you forgot to mention the third thing about the intercept besides vertically opposite angles and exterior angles. Oh, okay, so I mentioned 2. Exterior, I said exterior angle of a cyclic quad, and I said exterior angle on a triangle. Okay, so those are the 3. Okay, right. All right, now let's go. Oh, and then they say to us, prove, giving reasons, that Km is equal to ML. So, we're trying to prove that Km is equal to ML. Right. Can anyone tell us what can we do to do that? If we can prove that to be a 90-degree angle, right? And it means that it's the line from center perpendicular to a chord, right? Now, in this case, I want you to note we already have in triangle KMO, right? Triangle KMO. Angle K plus angle O plus angle M is equal to 180. Gonja, why is that? Okay, angle K, oh sorry, K2, not K. Angle K2 plus angle O, which is this guy, plus angle M. So I'm working in that smaller nyana triangle. Okay, right. The sum of the interior angles of a triangle. So I can say interior angle of a triangle. All right, sorry guys, I just need to hydrate nje. Yo kunin nkulum. All right. Okay. So if you're working in that smaller nyana triangle, then we can find a way to say, well, OK2 is 18 degrees. Angle O is 72 degrees. What then would be the size of angle? Or if we don't want to call it angle M, let's call it KMO. 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 Right, so what would be the size of KMO? Yeah, so that's equal to 180. So therefore, KMO would be equal to 90 degrees. Do you see? Once that angle is 90 degrees, Bona, you've got a line from the center that is perpendicular to a chord. And so if it's perpendicular to a chord, what does it do? It bisects the chord. Does that make sense? So therefore, in this case, we know that Km must be equal to ML. And the reason for that is that we've got the converse, or rather, let's say, line from center is perpendicular to the chord. Okay. Guys, I hope that makes sense. It does. Okay. Right. I want us to move on to the very next one. Right. So here's a little bit of proportionality theorems, especially when we work with those, particularly those ratios. Nah? Right. We don't have a lot of time, so let's try and rush through it. Nah? Let's try and rush through it. So, man, how? Simolucho, long paper for you Monday, Amo. Man, don't discourage other people. How? Okay. All right. All right. Quickly, let's look at it, guys. So they say in the diagram we've got triangle RDS. Okay. We've got triangle RDS. They say A, B, and C are points on RS and SD respectively, such that AB is parallel to DS. Okay, so it's given there, right? Sorry if it's not clearly visible, but I'll try my absolute best to walk you through it. So they said to us RB over BS. Now guys, here's what I advise. The moment they give you a ratio like this, right? So they said RB over BS is what? 5 over 3. Can you see? So I'm going to say this is 5x over 3x. That's a ratio. All right. Put a variable there. Okay. Right. The reason for that is that when you say 5 over 3, you might mistake it for a distance. Right. There's a difference between a ratio and a distance. So if you see there, but at 20, I know what that means. What does it mean? It's a distance. It's the units for that particular length, right? So if it's a ratio, indicate it with a variable. So for instance, if I used x on one side, then you're going to use y on another side, okay? Right, so please just don't use the actual values, nah? And then they said DC is 20 units and CS is 12 units, okay? Right, guys, we have to move towards wrapping up in this case. Now, the first question that they ask us, prove, giving reasons, that BC is parallel to AD, right? So we want to prove that this line here is parallel to that line over there, right? So remember, theorem 2 of your proportionality theorem says that if the sides are proportional, if two sides to a triangle are proportional, right, then it means that the third side must be parallel. Okay? Right. So in this case, I want you to note, so I'm going to try and find the ratio for this here. So kind of, if you look at this triangle kind of flipped around, right? So I'm going to work with CS over CD. If CS over CD gives me the same ratio as BS over, or SB over SB over BR. Yeah, so flip it around, né? So that you can see it properly. So look at it as this is the third side. This is the third side to our triangle. Okay? So if those two sides are proportional, right, have got the same ratio, then it means that the third side must be parallel. Okay? Right. Remember, Guti, that theorem simply states that a line that is parallel to the third side of a triangle divides the other two sides proportionally. Okay, right. So what's the ratio? So I'm going to say, all right, in triangle RSD, I notice that CS over CD is equal to 12. Now I'm taking the units. Can you see? Right? This is 12 over 20. Now how can I simplify that ratio? Both of those are factors of 2, isn't it? Oh, and in fact, more like factors of 4, rather. So 4 goes into 12 how many times? 4 goes into 12? 3 times, right? And into 20? 5 times. So what do you notice? The ratio is exactly the same as that of SB over RD. BR, right? So in this case, I've found the ratio to be the same. Therefore, I can say CS over CD is equal to SB over BR. And that is 3 over 5. And what can I say, guys? So therefore the lines are parallel. So BC must therefore be parallel to AD. And what do we say as the reason? It's the converse, right? So remember, we proved it the other way around. Ne? We found the lines proportional, the sides proportional, therefore it means that the sides are parallel. So the converse of the third side parallel, rather line parallel, sorry, converse of a line parallel to the third side of a triangle. Right, I hope that makes sense, guys. Okay. Yes. Sure. Yeah, I think that's still okay. Converse of the proportionality theorem, that's still fine. Okay. Right, and then the next one says, if it is further given that RD is 48 units, so RD, let's find it. Okay, RD is that entire side, ne? That's 48. And then they say calculate, giving reasons, the value of the ratio AD to AB. All right, AD to AB. So rather, let's do this. Would it be possible for us to find the size of AD? Right? So I want you to be very, very careful. So they gave us the whole side there, right, to be 48 units. And you can note, guys, I'm going to try and remove the other things so that it doesn't confuse a lot. Ne? I hope that you will understand. All right. So in this case, I want us to see. Right, I'm just removing this so that we can make it clear. So this entire side is 48. And I know that the ratio, now please I want you to note, already I was given Uti, those two sides are equal, are parallel, right? So I know that this side over this side, this is 48, not 45, right? That entire side is 48, but I'm looking for AD. Now, can I do this? Can I say AD over the entire side? Right? Now follow me properly. Nah? I'm looking for the side AD. Remember, this is also 5x, let's say 5y over 3y. Does that make sense? Right. So that means AD over, no, AD over RD. Right? AD, that's 3y, right? Divided by the entire side. Now this entire side would be 5y plus 3y. Does that make sense? So this would be 8y. Okay, right. In this case, we would have had to mention that this would be the same as BS over the entire side. I'm just rushing for time. I see we actually have 1 minute, but I'm just going to stretch it for the sake of this question. Right. And then we want the side AD. in this case, so I know in this case that RD is 48, and that would be 3 over 8. And so if I can just cross multiply, so AD would be equal to 3 over 8 multiplied by 48, man. Why do I keep saying 45? That's 48, nah? So I got the side AD. Are you guys with me, nah? What is it equal to? 3 over 8. Sen cartel. Multiply, so that's 18. So that's 18 units. Okay? So we were looking for AD to AB. Right. So for AB, it's really up to you which side you wanted to use. All right? I want you to also note, how would I get the side AB? So the side AB, I will say so this over this, right, divided by this over that will be equal to this over that. Does that make sense? In that entire triangle there. Okay, right. RD, it's in the smaller triangle. Do you agree with me? RB in the smaller triangle over RS in the bigger triangle will be equal to AB in the smaller triangle over SD in the bigger triangle. Does that make sense? So we're saying RB over RS is equal to AB over DS. Does that make sense? Why is that? The proportionality theorem again, those two sides are parallel to each other, right? But we already know the ratio of this. This is going to be, we said that's 5x over the entire side, which is 8. Né? So that's 5x over 8x. This would be equal to, AB is what we are looking for, divided by ds. Now you agree with me, that would be 20 plus 12, right? So that would give us 32. And of course we can cancel out our x there. So AB would be equal to 5 over 8 times 32. What does that give us? What's that? 20. Okay, that's 20 units. All right. And so, because we were looking for the ratio between AD and AB, so AD over AB, right? Konya, what was the size of AD? What it was 18 units, ne? Over 20. And remember, when you are representing it as a ratio, right? You don't use the units, Zakona, but you use the basic, the most basic ratio between the two. So in this case, that would be 9 over 10. 9 is to 10, ne? 2 goes into 18 9 times, and into 20 10 times. So that would be 9 is to 10. So in this case, that means that AD to AB would be equal to 9 is to 10. Okay, right. Guys, I've ran over time in terms of the time that we had allocated. I really would have loved to delve into the other questions, but I think for the sake of time, maybe I can try to see if tomorrow I can drop a video of the other questions. Now, thank you so much to all of you for joining us. For those of you that have been following us online, we are going to be doing this again for physical science. For those of you that are going to be writing physics on Wednesday, And we'll do the same again next week, Saturday. We might perhaps need to change the time for Saturday, but we will communicate about it. But I think it's really been a pleasure. Now, for those of you who don't know about our memberships, you can become a member to the channel, all right? And you can click and join as a member. We will do this a little bit more frequently for our members, right? I thought that I would open it up for everyone this time around so that you could see what going live or having a live lesson looks like. And I think next time we'll do it with a bit more of people in the audience, all right, so that you can hear their questions. It's always nice to hear people's questions. Guys, it's really a pleasure for me to see all of you, and thank you for supporting and following the channel. I hope that you will continue to do well, and I wish you all the best. Now, just the last thing that I wanted to say by way of advice, right? As you're going to write paper 2, sometimes, especially that last portion here, this one, right? Your proportionality theorem can really frustrate you, right? And I was going to show you an much easier way in which to go around it. Ne? Right, you just look for lines that are equal. You look for triangles rather, that are similar, and always try to use similar triangles, equal sides or proportional sides to actually get to the value of it. Okay, right. Sometimes it really does become frustrating. Okay, so my advice to you is please leave that section for last. Okay, so that if it gives you a little bit of an issue, you are able to navigate through it. Guys, I thank you, Professor, who is our member, Siyabonga, for the support. Okay, and I will be seeing you guys again next time. We've fairly kept a constant number, which for me does definitely say that you guys were paying attention. Appreciate it. I'll see you guys next time. Shap shap. Siyabonga. Right, I'll just end the stream.